I'm Chris Boland, a Cloud Platform Solution Architect with Red Hat, and I'm here to talk about Red Hat Service Interconnect, which is a way of deploying a virtual application network that allows you to connect applications across Kubernetes or OpenShift clusters, or from those clusters into on-prem private clusters, or even on-prem regular Linux or Windows machines. It can be done securely and easily, does not need additional VPNs, and since it works at layer 7 in the networking stack, doesn't need any elevated privileges. I'm going to do a demo for you of all of this in just a moment, but I wanted to show you how easy it is to get started. So we have our two clusters, and the first thing that we need to do is initialize the routers in each of those clusters. After the router has been initialized, we'll create a secure token and then transfer that token from one of those clusters to the other, thus creating a link between those two clusters. Once that token has been transferred, you can then expose only the required services, and those connections will happen over mutual TLS to make sure that they are private between just those two sets of interconnect routers. Let's go ahead and see how easy this is to do with a quick demo. So in this demo, I'm going to have two different OpenShift clusters. I will have a ROSA cluster, which is Red Hat OpenShift on AWS, and I will have an ARO cluster, which is Azure Red Hat OpenShift. So an OpenShift cluster in AWS and an OpenShift cluster in Azure. And what I'm going to do is deploy a MySQL database into the AWS cluster, set up all of my interconnect requirements, and then I'm going to access that database through the interconnect virtual application network from the cluster in Azure. And I won't need to set up any special networking, VPN, or firewall rules in order to make that happen. Let's see just how easy this can be. So the first thing that I'm going to need to do clearly is log into both of my clusters. So here I am logging into my first cluster. Now I'm going to create a new project in my first cluster to organize all of my code. Once my project is done, I'm going to use a little bit of the trick here and set a config inside my kube context so that I can switch back and forth between my clusters easily without having to change terminal windows. It lets me work in the same terminal window regardless of which cluster I'm trying to access. We'll set some labels on the namespace in this cluster. And then the next thing I'll need to do is do all of that same work, but in my private cluster. So we're logging into the private cluster here. We'll go ahead and create the new project within the private cluster. We'll then create that same config trick so that we'll be able to move back and forth between our two clusters in the same terminal window. And then we'll add a couple of labels to this just as we did in the first cluster. So here we go with the actual service interconnect steps. The first thing we're going to do is run the Scupper init command. This is going to install the Scupper router and the Scupper service controller in the current project where I'm logged in. I'll switch back to my public cluster first and then run that init command. Notice that I'm both enabling the console and enabling the flow collector. The console is a really nice web interface to show us all of our connected applications within the virtual application network. And if we enable the flow collector, that'll actually capture metrics for us so that we can take a look at throughput and latency and things like that. So we'll initialize our Red Hat Service Interconnect in one of our clusters, and it's installed in our Aardvark public namespace. Now what we'll do is change back to our private cluster and do that same thing. We'll run the Scupper init. This time I'm not going to pass in the console or the flow collector. You only need to do that once per virtual application setup. So we're now installed in both clusters, Aardvark public and Aardvark private. Switching back to the Aardvark public cluster, we can run the status command. So the status command gives us some pretty interesting information. It's running in interior mode, which means this cluster is not connected to anything else in its virtual application network. It's not exposing any services. And the status command also gives us the URL for the console. We'll take a look at that a little bit later on once we have some applications deployed. We'll switch back to our private cluster and we'll run that same Scupper status. It'll be very similar information. We're running in interior mode. We're not connected to anybody. There's no exposed services. This time, however, it doesn't mention the console because we only needed to create that once, as I mentioned earlier. So let's go ahead and create a link between these two clusters. The first thing we're going to do is create the token, and then we're going to use that token to create the link between the clusters. Switching back to my public cluster now. What I'm going to do is write the contents of this token to a file on my laptop. Now, this token is essentially the keys to the kingdom for this virtual application network. It should be kept secret like a password or secure credential should be, but for the purposes of this demo, let's go ahead and take a look at it. We'll cat out that secret.token, which I saved, and you can see there's an SSL certificate there, the password, and then who it was generated by. Remember, don't do this in your real-life clusters. Keep these tokens secret. So now what I need to do is move this cluster or connect this cluster to my private cluster. What's nice about having a console that is connected to both clusters simultaneously is that I don't actually have to physically move that token. That might not be true in your case. You might have to SCP or FTP it or sneakernet it over to the other cluster, but I don't have to do that. So I can go ahead and use my Scupper link create, and I pass in that secret token file. All right, and it created a link between my two tokens now. We can go ahead and check the status of that link. But before we do that, we'll go ahead and apply our database. So we're going to deploy a MySQL database, and this is the YAML file for that database. There's actually 2 bits to this. First is a config map. So this config map will be used once the database boots up, and you can see the init.sql there. We are going to create a database called book management. We are then going to create a table within that book management database, and then we're going to insert a bunch of rows into that database. So it'll pre-populate for us once the database boots up. And then we have our MySQL database deployment here. So we're going to run one instance of it. There's one replica. We've got some pods defined. You can see that we're running MySQL 8.0.32 on the default port of 3306. So let's go ahead and get this database installed into our private cluster. We'll apply our database kubernetes.yaml file. And then let's bounce over to our private cluster, our AWS cluster. Take a look at our projects. We can see that we have our Aardvark project here. We can look at our workloads for our Aardvark project. We have a database. We have a Scupper router and a Scupper controller. Or if we wanted to look at the graphical view, this is how those would look. The Scupper bits and then the MySQL database itself. Now, if you're familiar with Kubernetes, you might expect that we would have a service for our database, but we don't. The only service that we have defined right now is for our Scupper workloads. We don't have a service. We don't have any routes to that database. We don't have any ingress for that database. So at the moment, there is no way to reach this database from outside the cluster. Now what we're going to do is actually expose that database service to our Scupper network, our interconnect network. And we give it the port that we want it to be exposed on. That's the default port for MySQL, 3306. Now we've exposed that deployment named database as a service called database. And if we move back to our OpenShift cluster and go back to our services, now you can see we have this new service called database. And that's exactly what we would expect But here's something perhaps you didn't expect. When you look at the pod selector for that database, it's not actually pointed at the pod of the database itself. What it is pointed at is the Scupper router. It's actually pointed at the Red Hat Service Interconnect components for our virtual application network. So when we move back to our public cluster, let's see if we can actually see that database service. So we've logged into our public cluster now. We can do an OC get service database and see what we have. There it is. And in fact, we can look at this on the console as well. This is my Azure console. We can look at our workloads. And if we look at our workloads for our Azure console, and we change into the Aardvark public, we can see that we just have the Scupper bits. There's not a database deployed here. Remember, we deployed that database in the AWS console. However, if we are to come down to our networking section and look at our services, we do in fact have a database service. Now that's really interesting. This database service is pointed at, again, the Red Hat Service Interconnect components, the Scupper router and the Scupper controller. However, the database itself that this service is pointed to is an entirely different cluster. It's actually in an entirely different hyperscaler. We're on Azure right now, and this database is running in AWS. But can we use it? Let's find out. So the way we're going to test this is that we're going to run a MySQL client inside of our ARO cluster, inside of our Azure cluster, and we're going to connect to the MySQL database running in AWS. So the first thing that we're going to do is just execute the select version against that database. I want to make sure that I'm connected to the right version of the database. So our version is MySQL 8.0.32. If you remember from our YAML file, that's exactly the version that we're using here. So I feel pretty good about having deployed to the right database, although there could be a lot of MySQL 8.0.32 databases out in the world. Is this the one that I care about? Is this my book info database? Well, let's run this client again, but this time let's actually execute a SQL statement against that database. So here you can see we're using a SQL statement against the book management database, and we're going to select title, author, language from books. So let's see what this does for us. And remember, we're running this pod in Azure, and yet it is connecting through Red Hat Service Interconnect to a MySQL database running in AWS. And there it is. So that is the result of our SQL statement. We formatted it to look nice. It says a random selection of books from my bookshelf. If we scroll back up and take a look at that config map from earlier, you can see that this is exactly the data that I inserted into this database when it booted in AWS. And yet through Red Hat Service Interconnect, I'm actually able to access this data in an entirely different cluster, in an entirely different hyperscaler in Azure. So I mentioned that web console. Let's go ahead and take a look at what this will show for us. We'll check out our status again. And here is our URL. I'm going to copy this and open it in my browser. All right, and I'll need to log in. I left the default credentials in place. So let's go ahead and grab that. We will pull it out of the secret stored in Kubernetes. And this was the randomized password that was selected. Again, don't do this in real life. Keep your credentials secret. So I'm going to sign into my Scupper network. And you can see we've got two sites defined. We have our private site and our public site. And we can click into those and get a little bit more information. You can see that in our private site, they're running on these various AWS hosts. And if we go back and look at our public site, these are running on Azure hosts. We can see our components. So we've got the MySQL database and the MySQL clients. We have our various processes involved. We've got our addressing, our network. You can see through the process graph here which way the data is flowing. Here are the two clients that were participating in that virtual application network, reaching across through Red Hat Service Interconnect from Azure here in the orange over to AWS here in the blue. It's a really nice way of being able to visualize how all of your applications are wired up together regardless of what cluster they're running in. This actually completes our demo for today. And I hope you had a good time and were able to learn something.